This is Fun with Electronics, Project 3, Part 2, where we design Circuit 2, where a 555 timer is included to switch a pump controller. And since we don't have a pump controller, since that's not available to us, we're using a buzzer and an LED to indicate when the pump controller turns on and off. Yep, so here I have my own version of the circuit, which is the same basically. So here we have VCC, which is 9 volts. In the manual it says 12 volts, but 9 volts is also okay. So I recently before this video I did a quick test with 9 volts and it was working just fine. So you could go ahead do if you don't have 12 volts with you, or if you're lacking a power supply at home, then just you could go ahead and switch to a 9 volt battery. It should work the same way. So here basically, so here we have the 5 timer, right? All right, and then we have the VCC. We have the high level, the low level, which is connected to the to two voltage dividers. So since they're both the same value, they should produce the same voltage in between these two. And I actually made some calculations, which got me about point like 8.8 volts. It should come out of these 2 points, since the same resistor values are being used. All right. So in let me pull this up real quick. So in the in the 555 timer, we have two comparators, a flip flop and the output stage, basically, which is what we're focusing on, as well as the as three of the same resistor values. So basically we're comparing basically the value that the voltage divider is producing to either 1/3 or 2/3 of VCC, which is three volts for 1/3 and 6 volts for 2/3 of the overall uh, source value. So basically, so just a brief explanation. So basically, so we have one comparator connected to the flip flop, and another comparator connected to the same flip flop. So basically, um, both both the outputs of the comparators are connected to the inputs of the flip flop. So basically, pin two, the output of comparator that's connected to pin two is connected to to the S state of the flip flop. Sorry, and the output of the comparator that's connected to the threshold is connected to the other input of the flip flop, the R state. So basically, how it works. Um, so basically, when the water level reaches to a level uh, that's below the 1/3 boundary, which is 3 volts, then that means that the S state turns on basically. So S is equal to 1. We'll say it's 1. So it's high. While while the R state is off, so it's 0. So if S is 1 and R is 0, as you can see, I made a truth table right here. So basically, when S is 1, R is 0, then it sets to 1, which in this case the output of the 555 the 555 timer goes high, turning the transistor on, turning the relay on, and turning the circuit on, the LED as well as the buzzer. All right. So now, so when the water level reaches to the uh, to 1/3 of VCC, then basically the comparator goes to 0, because since we're applying around 8 volts, 9 volts, like 8.8 volts here to this comparator, to the I'll call it the S comparator. Um, since it's not less than 3 volts, then basically this comparator turns off. Basically, turns off. S equal to 0, goes low, while this remains low since the water it's let's say the water level is basically here in the middle. Since both comparators are at they're low. Looking here at the SR truth table, it's on hold. So basically, it stays on. The output stays on. It stays on until it reaches here to the high level, where where it compares where it com- where the comparator that's connected to, let's take a look, the comparator that's connected uh, to pin 6, you can see over here, compares to like 2/3 of VCC, uh, which is 6 volts. Since 8 is greater than 6, this comparator goes high. R is equal to 1, while S remains at 0. Let's take a look at the truth table. 0 and 1, then it resets. The output resets, and it goes low, turning the LED off. Turning the transistor off, turning the relay off, turning the LED and buzzer off when it reaches to the high level. Okay, now let's say we drain the water. We drain it, and it goes below. It goes below the high level. What happens? Then we get 0 volts here. 0 volts. Since there's no current flowing, it's just an open circuit for this level. It's an open circuit. So voltage is 0 over here. No current is flowing. Basically, sorry, no current is flowing. Voltage is 0, and this is false. Since this is false, this comparator goes to 0. Basically, it goes to 0, and remember this comparator the comparator that's connected to pin 2, it's still at 0. So basically we're still on hold. Basically, we're still on hold, and we're still on hold. So basically, the output stays off. The output stays off. The transistor stays off. At basically like the mid level, it stays off, and until it reaches to a level that's under the low level. And what happens? And what happens in that time interval? What happens? What happens is it goes below that. So basically, V1 is 0. Since no current is flowing, V1 is 0. And since 0 is less than 3 volts, then the statement holds true, which in which S equals to S, the S comparator or the S latch, equals to turns into 1 or goes high, while while the while the R comparator or the R state remains low at 0 basically. So it goes back to high basically. It goes to its set state. So it goes high, turning the output on, turning the transistor on, turning the relay on, turning the LED and the buzzer on, turning the pump on basically, allowing it to add more water again, and the cycle continues. I might not have given a very detailed and an understandable explanation, but that's pretty much what I understood from the 5-5 timer, from the 555 timer. Yeah. All right. So let's now move on to a circuit. So basically, so this is my circuit. This is the hardware version of it. Yeah, I emphasized a lot in the theoretical, basically in the 555 timer, because it was actually interesting, like knowing its function. Because I was asking myself, like, what does it do? What's the point of having a 555 timer? And which led me to just figure it out, which was actually interesting at the end. All right, yeah. So here we have basically the hardware. Here we have the buzzer. Here we have the relay, the diode, just to prevent any voltage spikes. And here we have the voltage dividers that are connected to pins 2 and 6. And here we have the 2 voltage dividers that connect to, the 1 voltage divider that connects to the base of the transistor. I have them both at 1K, and which connects to the relay circuit. All right. Mind the 2 transistors. Ignore those. All right. So time to test the circuit. All right. So when I connect the battery, the buzzer should turn on. And just a headphone warning. Just this buzzer is loud, so just be mindful of that. All right. So when I connect it, the LED should turn on. All right. All right. Now the water level is at its highest point. It's over or equal to the high level, basically. And just one thing I forgot to mention is basically the wires that I'm using for the high level basically is for the high level I'm still using this red wire over here for the high level, and for the low level I'm using this green wire that's connected to the white probe that's connected like all the way at the bottom. Not the bottom, but close to the bottom. Yep. Just ignore these wires. I'm using these for future circuits. Yep. For the remaining parts of Project 3. So yeah, And here we have the green probe that's connected to VCC. So yeah. All right. All right, so now we're gonna try to drain it and see the result. Do it carefully. Straining. This is not a proper draining, but as you can see, when it's at a level that's lower than its lowest, when it's at a level lower than the low level, then that's where it turns back on the pump controller, basically. So yeah, that's cool. As you can see, it's practically empty. Yep,